Hey folks, welcome back for another episode of Code Club. In the last episode, I mentioned that January is National Poverty Awareness Month here in the United States. And since we're in January, I thought I would dig into some of the poverty data that is made accessible from the US Census Bureau. Now, in that last episode, I took a swing at recreating this figure that came from a report that they published in 2023, so a year ago in January. And so on the top, they had the number of people in the United States in millions that were living in poverty, as well as on the bottom then, the poverty rate, the percent of people. And so because the US population has grown since 1959, the poverty rate stays flat, even though the number has gone up. Also on these plots, they had in the background these rectangles to indicate when recessions were occurring. And there were a number of other interesting things in this plot that got me excited. So at the end of that episode, one of my critiques was I wasn't sure that we needed two panels for the number of people in poverty as well as the poverty rate. And so in this episode, I'm going to recreate part of this plot, but focusing on the poverty rate. Something else that I'm interested in is what does the distribution for each year look like across the 50 states plus the District of Columbia, right? So do we have things that are wildly out of range from, the 0 to 25% that we have here? Or I guess it really goes from about 10% up to about 23 or 20% poverty range, right? And so in this episode, I'm going to create this figure with you. This figure, again, is focusing on the poverty rate, and each circle for each year represents one of the different states and the District of Columbia. The size of the circle is proportional to the total number of people living in that state, regardless of if they're living in poverty. And again, the y-axis position indicates the percent of people, percent of that total for that state living in poverty, right? And then the data that we have from the US Census Bureau goes back to 1980 up through 2023. As I mentioned in that last episode, there's a lot of great data available from the US Census Bureau. Down below in the description to this episode, I'll go ahead and put a link to this page where they've got 21 different tables of data. The one that I'm most interested in is going to be this table 19, number of poor and poverty rate by state. So this file, HSTPOV19, that's a very obscure name for a file, is an Excel workbook, or it's like a single page, so it's a worksheet really. And this will give us an opportunity to read in files from Excel. And so that's exciting, right? It will also give us an opportunity to hone our skills using dplyr, because this worksheet is a bit of a mess, right? And so you'll see that there's a title, but it starts on row 2. Up here is row 1. You can barely see it. It's so thin. I don't know why they're doing that. And then for each year, starting at 2023, they have the 50 states plus the District of Columbia, and then they go to the next state, right? So there's basically, I want to say like 43 or 44 tables here that have been appended basically one after the other. This is going to get tricky because for each of those subtables, they have a header, right? And so that header, of course, includes the state, the total population, the number in poverty, the margin of error for the number in poverty, and the percent in poverty plus the margin of error. So we're going to need to read this in and do some parsing to make a single data frame. We'll have the year, the state, the total population. Maybe we'll also get the number in poverty as well as the percent in poverty. I'm going to be ignoring the margin of error. Over here in RStudio, I have a povertybystate.r script ready to go for us to work with, along with the name of that hideous workbook. If you want to get this script as well as all of the code that I'm generating in today's episode, go down below into the description for this episode. You'll find a link to a blog post that you can go to get all of that code. All right, so we'll go ahead and load all of this, and including that readxl. And so readxl is a function that comes to us from the readxl package. By default, readxl will take the first row of that worksheet and make that the column headers. And so there's information here that I didn't think we actually saw in the workbook. And so sure enough, if I put my cursor in spot A1, again, it's really small, I actually see that there is text there, right? So that's interesting. And then like the second row is table 19, third is information about the data, and then row 4 is the year. And so you can kind of look through this and basically see that, right? So we have a whole bunch of NA values, because these columns or the data in these cells don't have tabs. And so readxl is going to use a tab to move things over. I'm actually surprised that it doesn't complain that the first 4 rows of the workbook don't have, what does it be, like 7 or 6 different columns, right? So that's interesting. And so now that we've read that in with readxl, we need to start thinking about how we're going to parse this so that we have the year, the state, the total number, the number in poverty, and the percent. And so I think the first thing I'm going to do is to tell readxl to ignore the column names. So we'll do call underscore names equals false. And so now we see that there are no column names, and that our column names are 3 periods followed by a number. And so then in that first row, we now have what had been the column name. So I need to think about my plan of attack for how I'm going to parse this data frame to get it into that format. And so there's 2 bits of information I need, right? So I need the year, but it's stored in a row in a column, right? I would rather the column be only years, but currently that column 1 is a mix of like other data, metadata, if you will, the year and the state. And so I think what we're going to end up doing is taking this file and maybe parsing it 2 different ways. One way to get the years, and the second way to remove the years as well as all of that metadata. So the years are the rows in the data frame that start with a number in that first column, right? So we can use some regular expression to pull out the rows that the first column starts with a number. Then what we could do again is to turn our attention to getting the state information. And so basically the stuff I've got highlighted here, we would want to get rid of, right? And so that would work by noticing that like this column 2, which is the total population of the state, right? That these values don't start with a number. So if we could then exclude things where column 2 doesn't start with a number, then we could get the data for the states. And so then we could merge together both the year information and the state information. That's my plan. We'll see how it goes. So let's start thinking about the years. I'm going to go ahead and call this raw data and store that in as raw data, the variable. And so now what we want to do is we want to do a filter, as I mentioned. And so filter is a function from dplyr that will return rows where the value in the parentheses evaluates to true. And so we'll do str detect from the stringer package. And so the string then is going to be what's in that first column. So that's going to be 3 periods and a 1, and we're going to put it in backticks. So the pattern then is going to be that we want it to start. So we're going to get that with that circumflex, I think it's called, or caret. And then we'll do back, lowercase d to match things that start with a numeric character. Now what we see is, sure enough, we have all those rows, and we've got a total of 46 different rows. I'm going to go ahead and print all of these out to just make sure that there are years. So we'll do print n equals inf, and we see that, yep, all of these are the years. And as we saw in the last episode, some of the years have a number in parentheses next to them, and that indicates some information, additional information is available in a footnote, right? The other thing that we'll notice is that 2017 and 2013 have 2 bits of information. And again, that's because the information between rows 8 and 12 was from one method, rows 1 through 7 is another method, and rows 13 through 87, I think we said, or 46 rather, is from a different method. Now what I want to do is go ahead and clean up to remove that footnote information, right? We'll go ahead and do a mutate on that first column, right? So using this backtick notation is a bit of a pain. I'll roll with it. I suppose I could have changed the name of it right after getting raw data, but let's roll with this, that's fine. And so we'll take that first column and we'll do a str replace, and we're gonna again operate on that first column. And so again, this is why it gets to be a pain to have these weird column names that it gives us by default when we don't give it column names like we defined on row 4. And so we'll replace that, and our pattern that we're gonna look for is a space and a parentheses with something in between it and another parentheses, right? And so Because a parenthesis has a special meaning with a regular expression, we're going to use 2 backticks because I actually want to match the open and closed parentheses. This period means match anything 0 or more times. I suppose I could also use a plus sign to match it 1 or more times. And so that would match something like this 11 in parentheses as well as this 8 in parentheses, right? And actually, instead of a period, I could do back D. And so that will match 1 or more digits within parentheses that follows a space. Get all that? Okay. And so it's upset with me, because I didn't give it the replacement value. So then we're going to replace that pattern it might find with nothing. And so now what we get are our years without that footnote number in the parentheses. Now what I'll do is go ahead and pipe this to a select, and select will allow us to rename that column. And so I'll do year equals that period 1. And so now what we get is the 1 column, and it's called year. But it's a character type, right? We want that to be a numeric. And so we can mutate year as .numeric on year. And so now what we see is that year is a double. So now we have an issue where 2017 and 2013 are represented twice in the data table, right? And so for the first 7 rows, we're going to use one method, and the second set from 2017 to the first 2013, we're going to use a different method, and then from 2013 back to 1980 will be a third method. I don't really care what those methods are, but I do want to give them different coloring like we had in that last video. And so within this mutate, I'm going to create a new column that I'll call method. And we'll use a case when, like we did in that last episode. So case when, and so here you give it a series of logical statements and what you want the value to be if that logical statement is true. And so it'll execute that first statement. If it's false, it'll go to the second. If that's false, it'll go to the third, right? But if it's true, then it escapes out and doesn't complete the rest of those logical questions. So we'll do row underspace number. And so this will give us the row number of the data frame. So if that is less than or equal to 7, then the method we're going to call C. And so now what we see is that we have this column method where from rows 1 to 7 are C, okay? And so we'll do the same thing now. So we'll do row number, and I think it's row 13, but I'm not positive. So I'm going to go ahead and take this and do print n equals 30. And so let's see, yeah, so that is row 13. Okay, so if the row number is greater than or equal to 13, then we're going to give it A. And then if year is greater than or equal to 2013, and the year is less than or equal to 2017, then it's going to be B. And so it's unhappy with me. Why are you unhappy with me? Oh, and it's unhappy with me because I still have this print statement in here. All right, now we have our C, B, and if I pipe this to tail, I see that we also have the A's going back. So I could make A and C the same letter because they're going to get the same color, but that's cool. So again, we now have these years with the methods. And what I'd like to do then is I want to duplicate each of these rows 51 times because we have 50 states plus the District of Columbia. There's a method in dplyr called uncount. And so uncount will duplicate a row n times. So I need to create a column for that n. So to create a column, I can come back into my mutate and do n equals 51. And so again, now I have that 51. And now I can do uncount, and the weights will be n. What you'll see is that the first 10 rows are all C now, and they all have the same year, right? And we now have 2,346 rows, which will correspond to the length of the data frame once we've removed the year and all that other stuff that we didn't want to keep. So I'll call this year tibble. So what we want to get rid of now is this metadata, the year, as well as the header for each of our columns. So we can start by doing drop underscore NA to remove any row that has an NA character in it. And so now we see we removed those first rows, but we still have this header, and we're going to have that header for each year going down, right? And so now what we could do is to go ahead and do another filter. So we'll do filter, str detect. And what we're looking at here now is where the second column doesn't start with a digit, right? So this total population doesn't start with a digit. We want to get rid of it. This does. So we're going to keep anything that starts with a digit in that second column. And so we'll do backtick, period 2, and then we'll do a start with a digit, so that back D. And so now what we get are the state as well as all of the rows without that header. And we see that we now have 2,346 rows, which was what we had back up here for the number of rows in our year. So now we want to get this cleaned up a little bit more because we see that we have these horrible column names. We don't want all of the columns, and the columns that should be numeric are actually characters. So let's do a select to get the columns we want and give them a name that we want. So we'll do name equals period 1, and then we'll do total equals the second column, and then the number of people in poverty is going to be that third column, and then the percent is going to be that fifth column. And so now we've got the name, the total, the number, the percent. These three columns, though, are all characters, and so we want to mutate those to be numerics. And so I'm sure there's a special fancy way to do this with mutate. I don't know it. It's hard for me to keep track of these things, so I'm going to do it kind of the brute force way, where we will do total equals as dot numeric on total. And so we'll then repeat this same type of statement for our three columns. So we'll do number and percent. And then we'll move that closing comma. And now we have our columns, and they are properly formatted with the name of the state, the total, the number, and the percent. Actually, I put name here. I don't want name. I think I want state instead. Now what I can do is go ahead and bring in the year data. And so we'll pipe this to bind calls. So we're going to bind columns together between what we've got in this pipeline as well as the year tibble. And so if I include this in parentheses, I now get my tibble with all the state names and numerical information, as well as the year and the method. And so that's cool. Suppose we could test that this all works out by doing something like count state. And then we see that we have 46 values for all of our states. And why is it 46 instead of 44? Well, that's because there are 2 years, remember, where we have double information. So let's go ahead and remove this count. And I'm going to assign this to a variable that I'll call clean data. Now we're ready to start plotting our data. We'll take clean data, pipe to ggplot, AES, the x-axis, the year, the y will be percent. Let's start there, and we'll do geom point, and there we go. Hey, we have, for each year, we have 51 points. Again, we can't make much of that because, again, the points are just like right on top of each other. It's really just really densely packed in there, right? And so my vision isn't that we would know what like this state is up here or what this state is down here. I'm trying to get an overall sense of the variation across the different states, right? And so what I'd like is for these points to kind of fade into the background and to have a line over the top showing the national data. One thing I'm noticing, though, is that for 2013, it seems like there's more data as well as for 2017, and there is, right? Because we have, for those 2 years, we have 2 methods being used. So I think what we'd like to do is to take clean data and for those 2 years, let's synthesize the values together, right? And so we can pipe that to summarize. So we'll want the total to determine the size of those points. And we'll do mean on total. And then we'll do percent as the mean on percent. And again, if I just do that, I get the grand total and the grand percent. But that's not what I want. I want to do it by, and I'm going to do it by state and by year. So do state, comma, year. And so now what we see is that we have the state, the year, the total, the percent. Let's call this state data. And then instead of feeding clean data in, we'll feed in state data. And so now we see that there's half the points, right, in 2013 and 2017. So that looks good. Now we also want to change the size of those points by the total. So in here, within our aesthetics, we can do size equals total. And so now we see big chunky points, and that this bigger circle is 30,000 thousands, right? So it's like 30 million, right? And so these points are getting really big and bleed over between the years. We'll deal with that later. But for now, why don't we go ahead and turn that gray? So we'll go ahead and do color equals gray. Because we have a lot of overplotting, why don't we go ahead and turn down the alpha, the transparency. So we'll do alpha equals 0.25. What this means is that if we have 2 points right on top of each other, then we'll have 50% transparency. If we have 4 points on top of each other, it'll look like a solid gray circle like we just had. And so now we can see some of that density, right? Like my eyes kind of want to see some trends here, but we're going to want to draw in that line because our eyes can't scale the average percent by the size of the state. So why don't we go ahead and add in that line? And so to do that, we're going to need national data. So let's go ahead then and take our clean data. And again, that has the method as well as the year and the state. And we'll go ahead and do another summarize of percent. And that is going to be the mean on percent. And we're going to aggregate by the year and the method, not the state, right? Because we want one line for the whole country. And so now running this, we see that we have the year, the method, the percent, C, B, and A. And again, 2017 has 2 methods. So let's then call this national data. And then we can bring national data in with a geom line. And we'll do data equals national data. I'll do mapping with the aesthetics. So X is going to be year, Y will be the percent. And I don't want the size. And so because I'm dropping an aesthetic, I'm also going to do inherit.aes equals false. So let's go ahead and see what this looks like. And so I see I've got one line all through. I need to add another aesthetic here, which will be color equals method. So now we see that we have 3 different colors for the 3 different methods. And our eyes, I think, at least my eyes, do a decent job of tracking where I see kind of the density of the points. And so I think that looks pretty good. Let's go ahead and turn off that gray background so it's a little bit easier to see the contrast with our points. I'll add to this theme classic. And I think that does help make the data pop out a little bit more from the background. Good. So this is the basics of our plot. Now let's turn our attention to modifying our aesthetics. And so I think we'll start with the color. We can do scale, color, manual. And our breaks are A, B, and C. And then our values are going to be the colors, right? And so if you recall, the original had kind of this green theme for the percent. And so we'll give this a vector of, let's say, dark green for A and C. And then we need a lighter color for the middle. So if we did green, it seems kind of fluorescent. Let's see what that looks like. Oh, and I forgot a plus sign here. So that is fluorescent. So that, I think, sticks out too much. Why don't we go ahead and make the line a bit thicker so it's easier to see that line. We'll do line width equals 2. Yeah, so I think that makes that B stick out way too much. So if we did like green 2 or 3 or 4, I think 4, let's see what that looks like. So I think that's actually pretty good. It's fairly close to the dark green, but it's not exact, right? So you can kind of see that there's a difference there. Let's go ahead and change our line endings, because the line endings, when you get this thick, they're square, obviously, right? But you can really see that squareness. So let's make it round so it's a little bit more of a gentle appearance. Up here with line width, I'll do line end, and I'll say round. That gives us a nice round line ending, which I think is more attractive than that just kind of blunt end. So I think that's great for our line. I'm going to go ahead and turn off the legend for that. So we'll do show.legend equals false. Now let's turn our attention to the size of our plotting symbol. Again, kind of right in here, I see one circle that's really big, and that is bleeding over between the years. So back up here in geom point, down here then, we can do scale, size, continuous, and this will take an argument range. And by default, we see that it's 1,6, so the smallest is 1, largest is 6. So let's do like 0.5 to 2 and get a plus there. And so that certainly prevents that bleed over. I think we can get a little bit bigger. Let's go up to maybe 4. Things are not quite bleeding over. I think once we get rid of this legend, that'll open up more space so that some of these points aren't quite touching each other. So let's go ahead and do that. Again, with this geom point, we can do show.legend equals false. Yeah, and I think that certainly 4 is the right size there. Now, our points are gray, and I wonder if we want to give it maybe a green appearance so that it's, I don't know, it kind of fits with the whole motif, right? And so we have gray. If we did like green 2, okay, that's too bright. Green 3, that's too bright too. Let's see if there's like a light green. I want some color in here, but this green just isn't really doing it for me. We'll stick with this, and I think that will be okay. All right, we'll move on. So this is like, basically the plot, right? Now everything else is getting it to look more attractive and perhaps be a bit more polished in how we're doing things. So let's go ahead and add our title, maybe a subtitle and a caption, and fix up our X and Y axis labels. So back up here after geom1, I'll do labs, X equals year, capitalize that, Y equals poverty rate. We'll put that in %. And I forgot a plus sign here again. Good. Now coming back up for our title. So something that strikes me about this plot is that it doesn't really change, right? Like it basically bops around between probably 10 and 15% over the past 44 or 45 years, right? And so I think that's what I want the title to be. So I'll say the average national poverty rate has varied between XX and XX percents since 1980. So I have to get those 2 X's, but we'll get there. And then our subtitle, I'll say poverty rate at the state level is indicated by individual points, which are sized to their overall population size. Okay, all right. And then we're going to put a caption at the bottom to indicate where we got the data. Data collected and reported by the US Census Bureau in 2024. And I'm going to put in a line break here. So I know I'm going to be using GG text, and I'll say table 10 from, and then I'm going to put in the URL. Okay, so I pasted that in, and we got a plus sign at the end. So let's go ahead and see what this all looks like. All right, and so we've got our title and our caption. Let's go ahead now and make those look a little bit more attractive. I'm first going to turn my attention to plug in these X values in. And so we can do that with a tool called glue. So glue is a package and a function that allows you to insert values into text very easily. It's kind of like paste or paste 0, but I find much easier to use. So we need to add library glue. And then what I want is from the national data, I want to get the min and the max, right? And so what we see again is that we've got the year, the method, and the %, right? Go ahead and summarize this, and we'll do min equals min on %, and max equals max on %. And so we get 10.2 and 15.4, okay? And so I'll call this min max, and that's our data frame. And then I can do like min max $min to get the smallest value. But I notice that's got a bunch of trailing digits, right? So I'm going to pipe this to a round, and we'll round it to digits equals 1. And to kind of show you what that looks like, if we look at min-max, well, it's hard to see, but let's run what we had before, right? So that was that min. That gets us to 10.2. So if we had a case where it was like 10, right? So if we did like round 10 digits equals 1, that just gives us 10, right? So to make sure it shows a trailing 0, if there is a trailing 0, we need to add format. So do format n small equals 1. And so again, what that would do here is if I paste that and do format n small equals 1, I get 10.0, okay? So we want to do the same thing that we did for min for max. And I don't think that's going to change a whole lot for min and max because they don't have a trailing 0. But we'll go ahead and take that min max. And then down here, this XX and the other XX, remember we're within the glue function here. We'll use curly braces and I'll put min max $min. And we'll do the same thing over here for this XX. We'll do min max and $max. And so now we have the numbers in the title. Cool, eh? All right, so let's work on some theming to make those titles and captions look better. We'll do theme, we'll do plot.title.position equals plot, and we'll do the same thing for the caption. So we'll do plot.caption.position equals plot. Again, that's left justified everything. And we'll want to make the font a bit bigger. And when we make it bigger, it's no doubt going to wrap. So let's go ahead then and we'll do plot.title equals element text box simple. And I'll do the same thing for the caption, but we need to add library ggtext up here. And let's go ahead and do size equals, let's do 20 and color equals dark green. And we'll do face equals bold. So let's put some line breaks in here and a comma at the end. So I think it looks pretty good. The line height is a little bit taller than what I'd like, which creates a bit of a space in between the two lines. So we can modify that by doing line height equals 1. And you'll see that that pulls it together a little bit. I think that looks pretty good. Now let's think about the subtitle. And for the subtitle, we'll do plot.subtitle element text box simple. Let's do size equals 12. And so for the color, I think what I'll use is this lighter color that we used up here, this light green, right? And so we'll put that in quotes and a comma. And I'm trying to use this light green to match the light green of the points. I'm not feeling it. I think that's not good. So let's change the light green to be gray. Let's use a number, maybe like 40. It was like a darker. Let's do 60, 70. Let's do gray 70. And we'll use gray 70 up here as well. My thought is that by using color in the text and the points that align, it'll be clearer to our audience that they go together. I think that's good. We need a bit of a margin, I think, around that subtitle on the top and on the bottom. And so in that plot subtitle, we can add margin equals margin. And then the top, let's go ahead and do 10. The bottom, let's do 10. I think that's pretty good. Now let's turn our attention to the bottom, to that caption. And again, I put in the HTML, so we know that we're going to need element text box simple. So we'll do plot.caption equals element text box simple. And then we'll do hjust equals 0 because by default it's right justified. And it's complaining. We saw this in the last episode, and I actually did some research. What it's trying to do is it's trying to use an A tag to format this URL, right? And so what I can do is I can put backslashes before those forward slashes. And that will add enough breakup in the URL so that element text box simple doesn't think that that belongs within an A tag. Again, no errors. And then we see that we have our nicely formatted caption. Again, it would be nice to have a bit of margin at the top of this. And so we'll come back up here and I'll do margin equals margin. Let's do T equals 10. And I think that gives it some nice space. Let's give it a lighter gray color than what we had up here. So that was gray 70. Let's go ahead and do like color. Let's do gray 90. I wonder if that's too light. Let's see. Yeah, that's too light. So let's make this 70. And what happens if we make this 50? All right, I think that's good. Let's also go ahead and make our points 50. Again, I want these things to match as much as possible. So I still think that's too dark. Let's go ahead and put it back to 70. And I don't think people are going to notice the difference, right? They're going to think this gray goes with that gray. And again, I want the caption to be a lighter gray because it's not super important. I want it to kind of fade into the background. And I think I'll use the same color gray that we used with the caption for our labels on the X and Y axis. So now we can go down here. We can do axis.title equals element text, color equals gray 70 again. That gets our titles on the x-axis and y-axis to be that gray. Now let's do the same thing for our text. So we'll do axis.text equals the same thing, right? Okay, so again, the idea is that we want this line, this green line, and the fact that it's pretty horizontal to really stick out. So let's now modify our line and our ticks. So we'll again do axis.line equals element line, color equals gray 70, good. And now we want our tick marks to also be gray. So we'll do axis.ticks equals the same thing. So I think this looks great. I would like to add some grid lines because again, I think this has been relatively horizontal, that there hasn't really been much of a downward shift. And I think something that would help clarify that would be some grid lines. So to do that, we could do panel.grid.major, and I want to do it on the Y, not on the X. We'll do element line. And so that gets us 2 grid lines across the back. So I think I want it to be that lighter gray. And so let's just go ahead and make sure that it's the same gray 70. And that seems to be thicker and darker now. We do line width equals 0.25. So that makes it thinner. I wonder if we can make it lighter. What happens if we go to like 90? And I think that 90 actually works pretty well there. I don't think we need these tick marks on the y-axis, but I think we need more resolution on the y-axis, right? So let's go from like 0 up to 30. And so to do that, we can come back up here. We'll do scale y continuous, and we'll do breaks, seek 0 to 30 by 5s, and then our limits, let's do C0 to 30. So that's pretty good. We're never going to have a negative poverty rate. So I think what I'd like to do is to go ahead and remove the expansion on the y-axis. And so back up here with scale y continuous, we can add expand equals C 0, 0. And so I think that looks pretty nice. One thing I notice is that this 30 tick mark, that the line doesn't always go up to it. So maybe if we have the line go just beyond 30, it'll look a little bit more attractive. And so again, why don't we set the limits to 31? And I think that will look good. Then let's go ahead and remove those tick marks because I think the tick marks are extraneous when we have the grid lines. So again, in here with axis ticks, let's make the X tick mark that, and then our axis.ticks.y to be element blank. Very good. I think that looks pretty nice and is a really nice aesthetic. So we now have the x-axis, the years go every 10 years. And so maybe it'd be better to go every 5 years and to indicate those minor ticks. We'll come back up and we'll do scale x continuous, and we'll do breaks of seek from 1980 to 2020 by 5s. And so that gets us our 5s. We also have a bit of an expansion on both sides, however, now. So let's go ahead and remove that expansion, and we'll do expand equals C 0, 0. But because I don't want it to start just right at 1980 and right at the end of the data 2023, maybe our limits we can specify to be from 1979 to 2024. And so then that does remove some of that external padding, but doesn't put the data right on the axis, right? So I think that's pretty good. So let's go ahead and add the minor ticks. We saw how to do this in the last episode, and I want some more practice in doing that. And so there's a couple things that we need to do, right? So one of them is the guides function, as I recall. And for X, we'll do like guide underscore axis. And one of the arguments here is minor ticks, and by default, it's false. So we'll do minor.ticks equals true. And we need a plus at the end of this. Hey, we have some minor ticks. I don't know how it's defining those minor ticks, but they're there. I want those minor ticks to be every year. So to do that, we can come back up to scale X continuous, and we can then do minor breaks. We can do 1980 colon 2023, and that'll give us even 1 year spacing between those years. And so there we go. We now have those minor tick marks all the way across. I think there is a slight difference in the length of those tick marks, but it's kind of hard to see. So why don't we go ahead and make those ticks a little bit longer And so we'll do that with axis.ticks.length.x, and we'll do unit, and let's do 4 points. And so that's a bit longer. We can change the minor ticks. We can do axis.minor ticks, and I want the length on the x, okay? And let's do unit 2 point. And so, yeah, we now see that we have those minor tick marks that are shorter than the longer tick marks, right? I wonder if we made them a little bit longer. So if we did like 5 and 3, I think that looks better. I'm curious what happens if we invert them and have them go into the plotting area. We can do that with a negative sign before the 5 and the 3. So I think that looks pretty good. But those ticks are pretty thick. Why don't we go ahead and narrow them to be kind of the same as the grid lines. And so our grid major y was line width of 0.25. So I'm going to copy this. And so then for our axis ticks x, let's do the line width of 0.25. And that does the major and the minor ticks to both be that more narrow line thickness. I think that looks good. I think we do need a bit of a margin, though, on top of our axis text. I had axis text here for the x and y. So let's go ahead and set that to be y. And I'll copy this x. And then we need a margin on the x. So we'll do margin equals margin t. And let's make it, say, 3. So that didn't change a whole lot. What happens if we go to, say, 5? So that moved it off a little bit. Why don't we increase it to 7? And that looks better. Cool. Well, I'm happy with the way this looks. Let me know what you think, right? And so again, I think the take home is that really it's varied between 10.2 and 15.4%, but there's really no overall downward trend. Maybe if you squint at it, you can see a very small decrease over these 24, 25 years. But I think that's kind of wishful thinking, right? So again, I like this in that it brings in the individual state data. While we can't figure out what each of these points represent very easily, perhaps we could call out some of the outliers, but those outliers don't really matter if the overall change isn't very significant. And, if even like the overall variation across states isn't that great, right? And so one thing I look at this and I think is perhaps the range in variation is decreasing with time, right? Like, so out here, there's someone at like 3% up to like 23%. So a 20 percentage point difference. Whereas out here, we're at like 7% to like 18%. It's like 11 point, right? So an interesting question might be like, what does the variation between the most wealthy and the least wealthy state in terms of poverty rating, how does that change over time? But that's a different visual. And we're not going to do that today. I will leave that for you to experiment with and let me know what you find out. If there actually is a downward trend in the amount of variation across states within a given year in the level of poverty. Also, I hope what you take away from this is that there's so much data out there that allows us to explore really interesting questions that are really significant and have a big impact on society, right? Like poverty is a huge problem in a country as wealthy as the United States. And it's something that we need to do a better job of figuring out how to solve, right? That we haven't really made a dent in poverty in the last 24 years. That's pretty disappointing, right? And it might be interesting to see like, well, how do other countries do, right? And so again, your mind starts thinking about all the possibilities and ways that we can visualize data to answer interesting questions. So I would encourage you to do the same. If you come up with something interesting, or if you find a cool plot out there in the wild, by all means, let me know. I would love to explore that with you all here in Code Club. Until next time, please make sure that you're telling your friends about what we're doing here in these episodes and all the great stuff we're learning with dplyr, ggplot2, ggtext, glue, all these great tools. And I'll see you next time for another episode of Code Club.